The night of October 3, 2025, passed in silence over Mars. The red planet rotated slowly beneath a sky that, for once, held more than dust storms and scattered stars. Out there, in the frozen blackness beyond its orbit, something was moving, a silent traveler, ancient and alien, slipping past on a trajectory that did not belong to this solar system. It was not a meteor, nor a spacecraft we launched, nor a comet in the ordinary sense. It was 3I Atlas, the third confirmed interstellar object ever detected by humanity. And on this night, every eye humanity had near Mars was fixed on it. They had prepared for months. NASA's Mars orbiters had shifted their positions. ESA's Mars Express had been loaded with special observation sequences. The Trace Gas Orbiter had been pointed toward the void. Even the dusty cameras of Curiosity and Perseverance had been adjusted to capture distant sky frames. This was not a routine flyby. This was a historic moment. For the first time in human history, multiple spacecraft were simultaneously observing an object that came from another star system, at the precise moment it passed closest to Mars. Back on Earth, the comet was invisible, swallowed by the blinding light of the sun. Ground-based telescopes could no longer follow it. Hubble and Webb had observed it months earlier, but now, the final stretch of its inbound journey unfolded far from terrestrial eyes. Only Mars, sitting in its lonely orbit, offered the perfect vantage point. And waiting there, like silent sentinels, was a fleet of robotic observers, ready to catch 3I Atlas at its most revealing moment. The rendezvous distance was just 28 million kilometers. In cosmic terms, that is nothing, 10 times closer than its future approach to Earth in December. For a brief window of time, the alien visitor swept through an angle that no telescope on Earth could achieve. From Mars's perspective, its glowing coma stretched across the darkness, faintly illuminated by the distant sun. The spacecraft orbiting Mars turned their instruments toward it with an intensity usually reserved for planetary science. This was not merely about capturing pretty pictures. It was about deciphering a mystery that had begun to trouble astronomers for months. Why was this flyby so important? Because for weeks, whispers had spread through the scientific community that 3I Atlas might not be a normal comet at all. Early spectral analyses had hinted at anomalies. Its orbit was unusual but stable, its activity pattern strange, its tail unlike that of any known long-period comet. And then came the compositional hints: nickel in abundance, persistent emission at unexpected wavelengths, and a mass so great that even solar radiation pressure barely nudged it. These were not the signatures of a fragile ball of ice and dust. As the object approached Mars, the sense of urgency grew. The sun was swallowing its trail from Earth's point of view, making Mars the only window left. Mars Express, with its high-resolution stereo camera, prepared to image the nucleus as it passed. The Trace Gas Orbiter readied its spectrometers to sniff the gases streaming from the object's surface. If there were methane, methyl alcohol, or other molecules that originated outside the solar system, this would be the moment to detect them. And if somehow, the object was not natural, if it was hollow, metallic, or producing artificial signals, this was the best chance humanity had ever had to find out. The intrigue ran deeper than just scientific curiosity. This was the third interstellar object ever observed, and the most massive. Oumuamua had come and gone, strange and enigmatic, leaving more questions than answers. 2I Borisov had blazed through like a classic comet from another system. But 3I Atlas was different. Its behavior was too stable, its coma too chemically complex, its mass too staggering. And now, as it swept past Mars, there were no atmospheric distortions, no Earth-based limitations, no light pollution, only the raw sensors of. In control rooms across Earth, teams stayed awake through the Martian night. Screens filled with streams of data, raw images, spectrometer readouts, time-stamped packets from deep space. It would take weeks to analyze. The spacecraft could not transmit everything at once. The bandwidth from Mars was limited, and priority was given to certain instruments. But what mattered most was that the data existed. For the first time, humanity had watched an interstellar traveler from two vantage points, from afar months earlier, and now, up close, near another planet. As the object passed its closest point, something unexpected happened. The coma brightened slightly, flaring for just a few hours. Some researchers suggested it was outgassing triggered by solar heating. Others whispered about more exotic possibilities, speculative. The brightening coincided almost exactly with the period when TGO's instruments were taking their deepest spectral measurements. If there were anomalies, they were now locked somewhere in those terabytes of Martian orbital data, waiting to be uncovered. Down on the Martian surface, the rovers gazed up. Perseverance captured a faint streak in the night sky, an alien comet seen not from Earth, but from another planet's soil. Curiosity's cameras strained against their limits, producing grainy but valuable images. These would help calibrate the orbital data and confirm the comet's apparent brightness. The symbolism was powerful. Robotic explorers built by Earth, standing on Mars, staring into the darkness at a messenger from another star. Back on Earth, the news broke slowly. NASA and ESA confirmed that the flyby had been observed successfully. No images were released immediately. Instead, carefully worded statements spoke of historic data acquisition and unprecedented opportunities for analysis. The public waited. The scientific community buzzed with speculation. What had they seen? What would the spectra reveal? Would this be another frustrating mystery, like Oumuamua, or a breakthrough? No one yet knew that the data collected on October 3rd might contain something extraordinary. If 3I Atlas truly was not a comet, if it was something else entirely, this was the night when the first clues were recorded. And Mars, silent and red beneath the stars, had been the witness. Long before the night of the encounter, preparations had begun in silence. It wasn't the kind of mission that makes front-page headlines or stirs dramatic countdowns. This was patient work, calibration, positioning, scheduling, an orchestra of machines spread across millions of kilometers, aligning themselves for one moment of convergence. The target was elusive, faint, and swift. But Mars was perfectly placed, and so every instrument humanity had stationed there was drafted into service. Months earlier, when 3I Atlas was still inbound from the outer reaches of the solar system, NASA and ESA had already recognized that Earth-based telescopes would lose sight of it as it passed behind the Sun. The only hope for continuous observation was to use Mars as a forward outpost. The red planet's orbit offered an angle that would allow spacecraft to observe the object even when Earth could not. Engineers calculated the exact timing, October 3, 2025, the moment when 3I Atlas would sweep by at a distance of 28 million kilometers. In cosmic terms, this was close enough for high-resolution imaging and spectroscopic detection. Spacecraft do not simply turn their cameras toward deep space on a whim. Every movement consumes fuel, power, and precious time. Mars Express and TGO had to be carefully maneuvered to ensure that their instruments would be aimed correctly during the flyby. Tiny thruster burns adjusted their orbital positions weeks in advance, while mission planners carefully designed observation sequences to match the object's expected trajectory. Even small timing errors could mean missing the moment entirely. The comet's speed was tremendous, and its apparent motion across Mars's sky would be rapid, forcing the spacecraft to track it like a fast-moving target. The Trace Gas Orbiter held perhaps the most important role. Normally, its instruments sniff out the Martian atmosphere, searching for faint traces of methane and other gases that could indicate geological or biological activity. But for this event, the instruments would be turned outward, away from Mars. Its spectrometers would scan the faint coma and tail of 3I Atlas, looking for spectral fingerprints, unique patterns of light absorbed or emitted by different molecules. If the object carried exotic compounds from another star system, this was the tool that could find them. Mars Express, older but still formidable, would complement this work with imaging. Its high-resolution stereo camera, HRSC, was designed to map the Martian surface in exquisite detail, but it could also function as a deep space imager. By capturing multiple exposures and stacking them, scientists hoped to tease out images of the nucleus itself. Even at tens of millions of kilometers, a well-timed sequence could resolve features no Earth-based telescope could match during this phase of the comet's journey. The ground-based rovers had the strangest assignment of all. Curiosity and Perseverance, built to study rocks and soil, were now tasked with astronomical observations. Their cameras were not meant to chase comets, but Mars's thin atmosphere gave them an advantage. No thick cloud layers, no light pollution, and minimal atmospheric distortion. By pointing their mass cameras toward the sky, they could capture long-exposure frames of 3I Atlas as a faint moving point, offering a ground reference that orbiters could use to refine their data. As the date approached, mission control rooms around the world buzzed quietly. There were no grand press events, no flashy trailers. But among planetary scientists and astronomers, tension ran high. This was a one-shot opportunity. If the instruments failed, if the tracking sequences misfired, if a solar flare interfered with data transmission, there would be no second chance. The object was moving on a hyperbolic path. Once it passed Mars, it would never return. The precision required was staggering. Consider the geometry. Mars orbiters circling a rotating planet, pointing their narrow instruments toward a rapidly moving target tens of millions of kilometers away, at just the right moment, without the benefit of real-time control. Commands had to be sent days in advance, pre-programmed, relying on predictive models of the comet's trajectory. Any deviation could cause the object to drift out of the instrument's fields of view. The flyby was not a leisurely observation, it was a tightly choreographed cosmic dance. Meanwhile, the comet itself remained stubbornly enigmatic. Even as it approached the inner solar system, it did not behave like a typical comet. Its brightness curve was erratic. Its tail seemed diffuse, oddly structured, as if shaped by forces other than solar wind alone. Amateur astronomers had speculated about fragmentation, but professional teams found no clear evidence of that. Others suggested that its rotation was irregular, tumbling in a way that defied simple modeling. And beneath it all lay the question that gave this encounter its electric edge: was it natural, or was it something else? By mid-September, the final observation schedules were locked in. Orbital maneuvers were completed. Data pipelines were cleared to prioritize transmission from Mars orbiters back to Earth's deep space network. Engineers double-checked redundancy systems. Every part of the Martian observational fleet was committed. If anything went wrong, they would at least have multiple instruments collecting data simultaneously, improving the chances that something meaningful would come through. As the comet closed in, the scale of the operation became clear. Mars, a cold and silent planet, was about to become the stage for one of the most ambitious astronomical observations in history. Not because of the technology involved, though it was formidable, but because of what was at stake. The mysteries of 3I Atlas had unsettled even seasoned astronomers. A core of extraordinary density. A composition that made little sense for its temperature. An orbit that raised eyebrows at every observatory. And now, here it was, racing toward its Martian rendezvous. In the days leading up to October 3rd, the object slipped behind the Sun from Earth's perspective. Telescopes fell silent. News cycles moved on to other stories. But in the quiet corners of space science, all attention shifted to Mars. For a few weeks, the red planet would hold the key to a mystery unfolding far from home. In the thin Martian atmosphere, twilight descended. Above the rust-colored plains, stars emerged with crystalline clarity. Among them, faint but steady, a greenish glow could be detected by sensitive instruments, 3I Atlas approaching. Its hue came from ionized carbon and diatomic molecules, producing that characteristic emerald tint that many interstellar objects display as they near the Sun. The rovers captured their first calibration frames, while orbiters began continuous monitoring. No one knew exactly what the next 48 hours would reveal. But for the first time, Mars was not merely a world to be studied, it had become humanity's forward outpost for peering into the unknown. And somewhere out there, in the dark, the object from another star moved closer. As the object drew nearer, a subtle but decisive change began to unfold across the Martian sky. What had been lines of code, trajectory charts, and predictive models transformed into real observations. The fleet orbiting Mars awakened, each probe falling into its role with mechanical precision. There were no cheers, no applause, only the silent execution of sequences written weeks earlier. The encounter had begun. High above Mars, Mars Express adjusted its orientation. Its sensors clicked into their programmed positions, and its high-resolution stereo camera locked onto coordinates just ahead of the comet's expected path. The camera's job was to capture multiple rapid exposures, building a composite that could later be stacked to reveal faint details otherwise lost in noise. The spacecraft's reaction wheels whirred softly as it tracked, compensating for Mars's rotation and its own orbital motion. It was like trying to photograph a distant bird while riding on a moving carousel, blindfolded, relying only on perfect timing. The trace gas orbiter followed suit. Its spectrometers began their delicate dance, scanning along the projected tail path of 3I Atlas. Each skin was a narrow stripe through space, collecting photons that had traveled millions of kilometers, filtered through the thin gases around the object. Every element and molecule would leave a telltale signature in that light, small dips and spikes in intensity that scientists would later match against catalogs of known substances. This was the most critical part of the entire operation. If there were anything unusual in the composition of 3I Atlas, whether exotic ices, unexpected organics, or something even stranger, it would show up here. The first data packets reached the Deep Space Network just minutes after the sequences began. At control centers in Europe and the United States, glowing displays filled with incoming telemetry. Engineers monitored signal strength, verifying that nothing had gone wrong. The comet's faint emission lines were being captured. Even at this early stage, there were already hints of complexity in the spectra, but it would take weeks to clean, calibrate, and interpret the data. The important thing was that the instruments were locked on target. Down on the Martian surface, Perseverance stood beneath a cold, still sky. Its mass cam, designed for geology, was now aimed at the heavens. The rover's software had been carefully updated to allow it to perform longer exposures than usual, pushing the limits of its imaging system. The resulting pictures would not be breathtaking. They would be grainy, faint, and smeared by the rover's slight vibrations, but they carried an unprecedented perspective. Never before had humanity photographed an interstellar object from the soil of another planet. Curiosity, older and more limited, followed suit. Its cameras were less sensitive, but even a few scattered photons could provide useful calibration points. Meanwhile, the Trace Gas Orbiter began a secondary task. After the initial tail scans, it turned its spectrometers toward the coma itself, the luminous envelope surrounding the nucleus. This was where the real puzzle lay. Early Earth-based observations had shown an unusual abundance of nickel emission lines. Under normal circumstances, nickel should not sublimate at the cold temperatures of a distant comet. Its presence in the gas cloud around 3I Atlas made little sense. Some scientists suggested that the nickel wasn't coming from thermal activity at all, but from impacts or fragmentation releasing metallic grains. Others entertained stranger possibilities, speculative. Perhaps the object contained industrial alloys, relics of processes that did not occur naturally in our solar system. As Mars Express's images began to arrive, mission scientists leaned closer to their screens. The first frames were noisy, filled with stars and cosmic rays, but buried in the data was a faint, elongated glow. Frame by frame, the nucleus and its surrounding structures began to emerge. The shape seemed irregular, but massive. Estimates of its core size would later be refined, but even in these early moments, it was clear this was no fragile snowball. The brightness profile implied a dense, perhaps monolithic structure, 5 to 11 kilometers across, enveloped by a broad halo of gas and dust. The object's tail was equally strange. Instead of the clean, narrow stream typical of comets, the tail appeared diffuse and slightly curved, as though some additional force was shaping it beyond the standard solar wind dynamics. Models of tail morphology ran constantly in the background at mission control. None fit perfectly. Some researchers speculated about complex rotation states, jets firing in multiple directions, or volatile pockets releasing gas unevenly. Others wondered if the tail contained charged particles interacting with the Martian magnetic environment in unexpected ways. There was a moment, brief but unforgettable, when the comet flared. Instruments recorded a sudden increase in brightness, just a few percent, but unmistakable. It lasted less than 2 hours. Spectrometers captured the event in real time, noting corresponding spikes in certain emission lines. Later analysis would debate its cause. Some proposed a burst of outgassing as sunlight struck a fresh pocket of material. Others suggested it was an interaction with the solar wind. A few whispered more speculative ideas: speculative, controlled venting, signal-like periodicity, behavior inconsistent with known comet physics. For the teams on Earth, those hours were a blur of data streams, rapid checks, and muted excitement. The observation sequences were proceeding flawlessly. Every instrument was working. The comet was behaving unpredictably, but not evasively. Its mass, so great that even subtle forces barely affected its course, made its trajectory easy to follow, and the spacecraft had no trouble keeping it in view. Even as the encounter unfolded, the sense of scale was staggering. Light from the object took minutes to reach the orbiters, and then many more minutes to reach Earth. By the time scientists watched the data scroll across their monitors, the comet was already tens of thousands of kilometers further along its path. This was astronomy conducted on a moving stage, with humanity's robotic eyes scattered across worlds, trying to glimpse the truth of a traveler from beyond the stars. In the silence of Mars's orbit, no one could hear the faint hiss of gas escaping from the nucleus, the crackle of solar particles against dust grains, or the whisper of an object older than Earth passing by. But the instruments did. They translated the silence into light curves, spectra, and pixelated images. And somewhere within that flood of information, the first real clues to the true nature of 3I Atlas were hidden. By the time the flyby reached its midpoint, mission controllers knew they had succeeded. All primary sequences had executed without fault. The comet was now moving past Mars, beginning to recede. But the real work was only just starting. The data, terabytes of it, would have to be carefully processed, cleaned, and interpreted. And as scientists began that painstaking task, a question hung unspoken in the air. Had they just recorded the signature of a natural wanderer, or the first solid evidence of something else entirely? As the last fragments of the flyby sequence played out, the orbiters returned to their usual routines. Mars Express resumed scanning the surface of the red planet. The trace gas orbiter shifted its instruments back toward the thin Martian atmosphere. The rovers turned their cameras downward again, to the rocks and sands they had studied for years. To anyone glancing at mission telemetry, everything seemed to return to normal. But inside data centers scattered across Earth, normalcy was an illusion. Something extraordinary had just been recorded, and the task of deciphering it had begun. The first hints came from the spectral data. As scientists began to clean the raw information from TGO's instruments, they noticed familiar molecular signatures: carbon, cyanide, faint traces of methanol, but layered among them were patterns that made them pause. The nickel lines were there, as expected, but their intensity was astonishing. For a comet in that region of space, those signals should have been negligible. At the temperatures 3I Atlas was experiencing, nickel should have remained locked in solid grains, not freely vaporizing into the coma. And yet, the spectrometers clearly showed nickel-bearing molecules streaming from the object in remarkable abundance. This was not the first time nickel had been detected in a comet's coma. Even in our solar system, some comets show faint nickel emissions, often when they are close to the Sun, where intense heating can liberate metallic compounds. But 3I Atlas was far from perihelion. It was cold. There was no straightforward thermal explanation for what the instruments were seeing. Some researchers proposed that the nickel was not in molecular form but being released as tiny metallic particles, perhaps shattered from the surface by internal pressure or micro-impacts. Others wondered if some unknown exothermic reaction was taking place inside the object, heating it from within. And then there were the more unsettling interpretations, speculative. Nickel, in pure or alloyed form, is a critical component of industrial metallurgy. On Earth, it is used in stainless steel, high-performance alloys, and spacecraft components. Its presence in large, pure quantities in space has sometimes been theorized as a possible indicator of artificial processing. No one was ready to make that claim, not after the controversies surrounding Oumuamua, but the thought lingered, unspoken, in the back of many scientists' minds. Was this object truly natural, or were they looking at the byproducts of something manufactured, something left adrift between the stars? To answer that, they needed to understand its mass. And the mass of 3I Atlas was turning out to be just as bewildering as its composition. Unlike most comets, which display noticeable non-gravitational accelerations due to outgassing, this object barely budged. Its trajectory through space followed a clean, hyperbolic curve, unaffected by the small thrusts produced when sublimating ice's escape into space. This implied a course so heavy that these forces were insignificant compared to its inertia. Preliminary estimates, refined using the high-resolution images from Mars Express and the TGO's tracking data, suggested a nucleus between 5 and 11 kilometers across. But that alone did not explain the stability of its motion. Calculations from multiple teams converged on a staggering figure, at least 33 billion tons. That made 3I Atlas roughly 1,000,000 times more massive than Oumuamua. For comparison, that's heavier than Mount Everest, far denser than any known comet of similar size, and completely unlike the porous, icy aggregates typically seen among interstellar visitors. This was not a fragile object. It was a colossal, compact body, pushing through space like a silent asteroid, barely reacting to the sun's influence. The shape data made the puzzle even more intricate. The Mars Express camera sequences, when combined with orbital parallax measurements from TGO, allowed scientists to model the nucleus's silhouette during the flyby. The result was irregular but blocky, far from spherical, yet without the delicate, frayed structures one might expect from a heavily eroded comet. There were hints of angular features, flat planes interrupted by jagged edges, though the resolution wasn't high enough to draw definitive conclusions. Some in the imaging teams described it quietly as uncomfortably geometric. Others cautioned that low light and noise could easily create misleading impressions. The debate ignited quickly. This was precisely why the Mars flyby had been so important. From Earth, 3I Atlas was now hidden behind the Sun, inaccessible to direct observation. Had these data not been collected from Mars, much of this information would have been lost forever. Instead, humanity found itself holding a puzzle far more complex than anyone had anticipated. A cold object shedding metallic vapors at the wrong temperature. A nucleus of staggering mass, resistant to solar forces. A silhouette that hinted, perhaps misleadingly, at unnatural shapes. At research institutes, meetings began to stretch long into the night. Teams from ESA and NASA shared preliminary findings over encrypted links. Astronomers debated models of internal heating mechanisms, searching for natural explanations. Could radioactive decay inside the nucleus be generating enough heat to sublimate metals? Could friction from rapid rotation produce localized hotspots? Every theory had problems. None fully accounted for all the observations. And as the data poured in, more anomalies appeared. Spectral analysis revealed subtle, periodic fluctuations in certain emission lines, almost like pulses. These were not signals in the conventional sense, but their regularity was unexpected. Some thought they were instrumental artifacts, others considered rotational modulation, where different active regions of the nucleus rotated into view at fixed intervals. A few entertained more exotic ideas, speculative, wondering if the object's interior could host mechanisms unfamiliar to natural bodies. Caution prevailed, but the intrigue deepened. Outside the scientific community, rumors began to spread. Amateur astronomers, locked out of direct observation due to the sun's glare, speculated wildly on forums. News outlets, sensing a story, hinted at alien probes and interstellar craft, without evidence. Space agencies maintained their careful silence, reminding the public that scientific analysis takes time, and that extraordinary claims require extraordinary proof. But the mystery had momentum now, and it would not slow down easily. Through all of this, 3I Atlas continued on its way, indifferent to human curiosity. Its hyperbolic trajectory carried it past Mars and onward toward the Sun. Soon, it would reach perihelion, swinging through its closest point before arcing outward again toward deep space. The Mars encounter was over, but the data it produced had only begun to speak. And within those terabytes of information lay the potential to either solve a cosmic riddle, or deepen it beyond anything humanity had faced before. In the days immediately following the flyby, the data flowed steadily back to Earth. Streams of telemetry from Mars orbiters were carefully routed through the deep space network, checked for errors, and archived in massive databases. At first, it was simply too much information to comprehend. Terabytes of spectral scans, imaging sequences, and timing data arrived in fragments, waiting to be stitched together like pieces of a puzzle scattered across a table. What had happened over those few crucial hours near Mars was extraordinary, but understanding it would require patience, precision, and above all, honesty in the face of the unknown. The first analysis meetings were cautious affairs. Teams at ESA's Mission Control in Darmstadt and NASA's Jet Propulsion Laboratory gathered in dimly lit conference rooms, surrounded by walls of projected graphs and preliminary images. At this early stage, the focus was on calibrating instruments, removing noise, and identifying potential errors. But even with conservative methods, the numbers kept pointing to the same unsettling conclusion: the mass of 3I Atlas was far higher than anyone had anticipated. Using Mars Express's stereoscopic images, scientists reconstructed the object's apparent dimensions. The nucleus appeared to be roughly 5 to 11 kilometers across, depending on albedo assumptions. But its dynamical behavior, the way it ignored subtle forces like outgassing jets or solar radiation pressure, implied a bulk density closer to that of solid rock or even metal. Typical comets, composed of porous ice and dust, have densities of only 0.5 to 0.8 grams per cubic centimeter. 3I Atlas appeared to be far denser, potentially exceeding 5 grams per cubic centimeter. That pushed it into the realm of iron meteorites and some asteroids, not fragile visitors from the Oort cloud or beyond. Some of the mission scientists exchanged wary glances during these meetings. They had seen puzzles before. Oumuamua had puzzled everyone with its strange acceleration and thin, flattened shape. Borisov had surprised observers with its pristine, icy structure. But this was different. Here was an interstellar object with the mass of a small mountain, wrapped in a greenish coma, shedding metallic vapors in the cold of deep space. It didn't behave like anything that had visited the solar system before. And its sheer size meant that whatever processes shaped it had to be profound. Debates over its shape quickly followed. The initial images from Mars Express were noisy but valuable. Through sophisticated image stacking and deconvolution techniques, scientists teased out a rough silhouette of the nucleus. The result was irregular, elongated, but surprisingly angular in places. There seemed to be large flat regions, sharply defined edges, and sudden breaks in curvature, features not commonly associated with naturally eroded cometary nuclei. Of course, noise can play tricks, especially when working at extreme distances, but the impression lingered. Some imaging specialists suggested that the shape could be the result of catastrophic fragmentation in its distant past. Perhaps a massive collision had broken it into blocks that later reassembled loosely through gravitational attraction. Others argued that rapid rotation might have stretched it into an elongated, irregular form, similar to how fast-spinning rubble piles sometimes distort under centrifugal forces. But none of these explanations fully accounted for the geometry that some images seemed to imply. A few participants in these early meetings hesitated before using the word structured, but the implication hung in the air. Parallel to the shape debates, gravitational modeling teams worked around the clock. By examining the precise trajectory of 3I Atlas during the Mars encounter, they could refine estimates of its mass and density. Mars's orbiters had captured subtle changes in the object's apparent position over the course of the flyby, allowing for a kind of cosmic triangulation. The results were consistent across multiple independent analyses. The object's mass was colossal. So large, in fact, that standard outgassing models predicted accelerations far greater than what was actually observed. It was as though the comet were almost indifferent to the forces acting upon it. These calculations triggered another round of theoretical speculation, speculative. If the object was natural, perhaps its core was composed of unusually dense materials, iron, nickel, or exotic metallic alloys forged in the heart of some long-dead star. Alternatively, maybe it was the remnant core of a planetesimal from another system, stripped of its outer layers and sent drifting through the galaxy after a cataclysmic impact. Such remnants could be dense, massive, and irregular. But if so, why did it still emit a greenish coma like an active comet? Why the strange nickel emissions at low temperatures? The pieces did not fit neatly together. More daring hypotheses circulated quietly, away from official reports, speculative. Some researchers wondered whether the object could be hollow, an ancient, derelict vessel of some kind, so massive and dense in its frame that outgassing jets made no measurable difference. Others speculated about alien megastructures, about probes designed to withstand interstellar journeys, about the possibility that humanity had accidentally intercepted something far older than civilization itself. These ideas were not presented in formal meetings, but they appeared in private emails, hushed hallway conversations, and late-night chats between colleagues who knew they were venturing into speculative territory. For every wild idea, there were grounded scientists insisting on caution. Comets and asteroids have surprised us before. Nature is capable of producing structures and behaviors that challenge intuition. Unusual density might simply reflect a compact, metallic asteroid that retains some volatile materials on its surface. Angular shapes could be the relics of fracturing under extreme stress. Nickel emissions might have a natural, if poorly understood, explanation. But even the skeptics admitted, this was not a typical object. As the object continued its trajectory toward perihelion, new data from Mars slowly trickled in, further sharpening the mystery. The coma brightness fluctuated unpredictably. The tail displayed faint striations that did not match simple solar wind models. Spectral fluctuations repeated with an odd periodic rhythm, neither random nor clearly rotational. And the shape models, refined with better calibration, continued to hint at edges and planes where smooth curves were expected. Meanwhile, outside the closed circles of the scientific community, speculation was exploding. Leaks, half-formed interpretations, and snippets of data analysis found their way into online forums. Amateur astronomers posted speculative 3D models based on Mars Express imagery. Some news outlets ran sensational headlines claiming alien structures near Mars, while others dismissed the entire story as overhyped comet science. In truth, no one outside the data teams knew enough to say anything definitive. But the mystery was too alluring to ignore. Inside the labs, the mood was shifting from cautious excitement to something more complex. A mixture of curiosity, unease, and the weight of responsibility. If 3I Atlas was truly unlike anything encountered before, the implications were vast. But rushing to conclusions could damage credibility for years. So they waited, they analyzed, and they argued, knowing that somewhere in those streams of numbers lay an answer, or perhaps a deeper riddle. And out in space, 3I Atlas kept moving, silent and unchanging, following its hyperbolic path toward the sun. It offered no explanations, no clues beyond what the instruments had captured during its brief passage by Mars. It was humanity that had to piece together the story, from fragments of light scattered across the Martian sky. The comet was gone. For the observers on Earth, 3I Atlas had vanished into the brilliance of the sun, its faint, green-tinged tail swallowed by the glare of our star. The telescopes that had once tracked its path with obsessive precision could no longer see it. It was as if the sky had closed the curtain on a cosmic drama right at its most critical moment. And so, for the first time since its discovery, the comet became a creature of pure numbers, no longer visible, but existing in radio signals, archived data packets, and the whispered calculations of scientists working in long, sleepless shifts. On Mars, the encounter was over. The spacecraft orbiting the red planet had done their jobs with perfect timing, capturing everything they could as the green interstellar visitor passed by at a respectful cosmic distance. Now their instruments turned back toward their regular duties, scanning Martian canyons, tracing atmospheric gases, listening for subtle tremors beneath the dusty surface. But deep inside their onboard memories, hidden among the daily telemetry, were the frames and spectra that would decide how history remembered 3I Atlas. Back on Earth, the teams responsible for processing the raw observations had entered a kind of organized silence. It wasn't secrecy in the traditional sense, but the natural quiet that descends when something extraordinary is at stake. Before releasing any findings, every measurement had to be checked, cross-referenced, and verified. Instruments can lie. Software can glitch. A single uncorrected error can spiral into an international misunderstanding. So the data remained within the controlled walls of ESA and NASA analysis centers, guarded not by locks but by the complexity of its own nature. And outside those walls, the world began to speculate. The waiting stretched into days, then weeks. Every small update from NASA or ESA was picked apart by the public like crumbs dropped from a banquet table. A sentence mentioning unusual spectral readings in a technical briefing became the seed for hundreds of speculative videos. A vague tweet from a Mars Express engineer hinting that the data was complicated set off a wave of online theories. Some believed that the object was indeed a strange comet, unlike any seen before. Others were convinced that it was artificial, a relic from beyond our galaxy drifting into our solar system for the first time in recorded history. And somewhere between these extremes lay the quiet, careful work of scientists trying to separate truth from noise. Inside the laboratories, this waiting period was anything but idle. Teams worked in shifts, their offices lit by glowing computer screens deep into the night. Spectroscopists examined the chemical fingerprints of the comet's tail, searching for familiar patterns or unexpected anomalies. Dynamicists refined trajectory models, trying to detect even the smallest deviations that could hint at hidden forces. Imaging specialists ran complex deconvolution algorithms, coaxing sharper silhouettes from noisy frames taken by Mars Express and TGO. Each discipline was a piece of the puzzle, but the puzzle itself refused to reveal its picture. One of the most puzzling aspects remained the nickel emissions. Nickel, especially in the quantities observed, should not be detectable at such low temperatures. It implied either an unusually hot interior or a surface chemistry that behaved unlike any comet on record. Some researchers proposed that impacts or ancient collisions could have exposed metallic layers to space, slowly vaporizing under solar radiation. Others suggested that the object might be shedding micron-sized metallic dust that fluoresced under ultraviolet light. But no single explanation accounted for the consistency and strength of the signal. Meanwhile, the mass anomaly continued to loom over every discussion. The models agreed. This object was massive, and its trajectory bore the signature of something extremely dense and resistant to subtle forces. Yet it was clearly active, surrounded by a coma that should have created measurable non-gravitational accelerations. The contradiction was sharp and unresolved, hanging like a riddle between competing theories. Some joked darkly that the object seemed to obey its own private physics. As the days turned into weeks, the comet's position behind the Sun meant that no new data could be collected from Earth-based observatories. It was a blind spot that humanity had to simply endure. The next chance to see the object again would come at the end of October, when it approached perihelion, skirting the inner solar system before emerging once more into the night sky. But by then, the Mars data would either confirm or overturn many of the early suspicions. That was why the wait was so intense. The Mars flyby wasn't just another observational milestone. It was the key, the only set of close-range observations we'd get before the comet's trajectory carried it back out into interstellar space forever. The scientists knew this. In their meetings, they spoke in careful tones, weighing possibilities like fragile glass. No one wanted to make the mistake of a premature declaration, especially given the explosive nature of the rumors circulating online. They remembered how the case of Oumuamua had unfolded, the initial excitement, the wild speculations, the eventual frustration when data ran out before definitive answers could be found. This time, they had more data, much more. But they also had higher stakes. In quiet moments, some of the mission's scientists admitted to themselves that they felt something they hadn't experienced in years, a sense of genuine cosmic suspense. Not the manufactured kind that comes from headlines or dramatic documentaries, but the raw, real tension of facing a mystery that might not fit into existing categories. Was 3I Atlas simply a very unusual comet? A fragment of a long-dead world? Or was it something stranger, something that required humanity to adjust its understanding of what drifts between the stars? Speculative. The public's patience was wearing thin. Every time NASA or ESA delayed a scheduled press update, speculation surged. Some claimed the agencies were hiding the truth. Others thought they were waiting for irrefutable proof before making a sensational announcement. A few simply enjoyed the ride, captivated by the unfolding space mystery like an interstellar detective story. News outlets ran daily segments tracking The Visitor, while YouTube channels dissected every possible scenario. It was as if the entire world had joined a vigil, waiting for a revelation that might redefine our place in the cosmos. Behind the scenes, however, the scientists' motivations were simpler. They weren't hiding evidence. They were trying not to misinterpret it. History had shown, time and again, that extraordinary claims required extraordinary proof. And if they were to say that this object was anything other than a natural interstellar comet, the burden of evidence would be monumental. Weeks passed. The comet neared the Sun. Data processing neared completion. And somewhere, in the endless streams of binary code transmitted from the red planet, the truth about 3I Atlas was waiting to be uncovered. All that remained was to find it, and decide how, and when, to tell the world. The quiet days after the Mars flyby became something of a strange limbo. Across control centers in Europe and the United States, the hum of activity never stopped, but it was no longer the frantic, coordinated dance of spacecraft operations. Now, it was the slow, methodical work of data archaeology. Engineers and scientists dug through terabytes of telemetry like careful excavators in a buried city, aware that somewhere in these digital ruins lay a secret no one had uncovered before. In ESA's mission control in Darmstadt, the night shifts had taken on an almost dreamlike rhythm. The building was dimly lit, with only the soft glow of monitors reflecting off polished floors. People moved quietly, speaking in low voices, sipping coffee that had long gone cold. The images from Mars Express and TGO were slowly sharpening through meticulous processing, like old photographs being developed in a darkroom. Each pass-through noise reduction algorithms revealed something new, a faint structure in the tail here, a spectral anomaly there, subtle brightness fluctuations that defied easy explanation. At JPL, on the other side of the world, similar scenes unfolded. Rows of workstations displayed graphs, spectral lines, simulation outputs. The teams were tired but alert, sustained by adrenaline and the awareness that they might be the first humans in history to glimpse detailed evidence of something from another star system passing near Mars. There was a sense of historical weight in the air, like the quiet before the announcement of a major discovery, but stretched over weeks instead of hours. As data analysts refined their models, patterns began to emerge. One of the earliest surprises was found in the time series analysis of the comet's coma brightness. Instead of a smooth curve typical of most comets, 3I Atlas exhibited strange, periodic fluctuations, gentle pulses of brightness occurring at regular intervals, repeating over and over with near mathematical precision. Some thought it might indicate rotation, but the rhythm was peculiar. It wasn't the kind of irregular tumbling seen in other elongated bodies. It was clean, consistent, almost mechanical. The possibility that it was simply a resonance between solar wind patterns and the object's shape couldn't be ruled out, but neither could the notion that something unusual was driving these fluctuations. Another clue surfaced in the tail structure. Mars Express's HRSC camera had captured long exposure sequences that revealed extremely faint striations in the tail, almost like parallel threads. They were far too subtle to be seen from Earth, and they didn't match known solar wind interaction models. Some theorists proposed that the object might be releasing material in bursts, each leaving its own faint filamentary trail. Others speculated that the tail was interacting with interplanetary magnetic fields in a way that produced layered structures, similar to ripples in sand after waves recede. But beneath the careful wording of the reports, you could sense it. Nobody had seen a tail quite like this before. The nickel emission mystery deepened further. TGO's spectrometers had picked up clear signatures of nickel vapor, glowing faintly in ultraviolet wavelengths. The signal was stable and consistent, not a one-off artifact. In comets, nickel usually requires temperatures far higher than those present at the distance where 3I Atlas was observed. Some suggested localized heating, maybe impacts or focused solar energy on metallic inclusions, but the numbers didn't quite fit. The nickel emission lines were too sharp, too persistent. It was as if something inside the object was releasing this material in a controlled, steady way. Speculative. Internally, discussions began to grow more intense. Conference rooms filled with scientists debating interpretations, sketching models on whiteboards, sometimes erasing them moments later. There was no single explanation that tied all the observations together neatly. Some data pointed toward a massive, dense nucleus, possibly metallic. Other data implied unexpected activity and periodic behavior. Theories sprouted and withered in the span of a day. Was it a fragment of a shattered exoplanet? A dense, nickel-rich asteroid with a veneer of volatiles? A dormant interstellar core that had reactivated under solar heating? Or something more exotic that no one dared to put in writing yet? As the world waited, pressure on NASA and ESA intensified. Journalists sent daily inquiries. Space forums erupted with amateur analyses and conspiratorial claims. A few enterprising enthusiasts began overlaying Mars Express images with AI-enhanced models, producing striking but highly speculative renderings of the object's shape. Some of these showed enormous angular structures or grid-like patterns, which quickly went viral despite disclaimers about their accuracy. Agencies issued carefully worded statements reminding the public that no conclusions had been reached and that rigorous scientific analysis takes time. But the internet has never been good at waiting. The agencies were caught in a difficult balancing act. On one hand, they couldn't release preliminary data that might be misinterpreted and fuel misinformation. On the other, prolonged silence risked letting rumors spiral out of control. Some within ESA argued for releasing a few teaser images to calm public speculation. Others insisted that only peer-reviewed results should go public. In the end, they chose caution. Nothing official was released, and so the vacuum of information was filled with theories, leaks, and imagination. Within scientific circles, though, the mood shifted from curiosity to tension. Everyone understood that these observations were unique and unrepeatable. There would never be another flyby like this. If they failed to extract clear answers now, the mystery might remain unsolved for decades, just as it had with Oumuamua. And unlike Oumuamua, this object had given them better data. Mars had provided the perfect vantage point. The instruments had performed flawlessly. If answers existed, they were buried somewhere in this data set. Meanwhile, the comet was approaching its perihelion, the closest point to the Sun. By late October, it would slip behind the solar glare completely, hidden from both ground-based telescopes and most space observatories. After that, it would emerge again in December, on its way out of the inner solar system, fainter but still trackable. That brief post-perihelion window would be humanity's last direct look before it vanished forever into the void. And so the sense of urgency mounted. The Mars data had to be understood before the comet reappeared. Otherwise, the world would be looking at it again without truly knowing what it was. Late at night, in offices scattered across continents, individuals stared at the data, feeling the weight of cosmic mystery pressing in. For some, this was the culmination of decades spent studying dusty, icy visitors from the outer solar system. For others, it was the first brush with a question that seemed bigger than their field, bigger than the instruments they used. A visitor from beyond the stars had passed near Mars, and it had left behind whispers, enigmatic, tantalizing, half understood. Whether those whispers would resolve into a clear story or remain an unsolved riddle depended entirely on what happened in these quiet, intense weeks of waiting. By mid-October, a subtle change swept through the global conversation. The waiting had stretched on long enough that patience was beginning to fray. But something else was happening too. The comet was moving closer to the Sun. Its orbit carried it toward its perihelion, that brief moment when it would skim closest to our star before slingshotting away into the darkness. For astronomers, perihelion was not just another milestone. It was the furnace through which the object would pass, revealing secrets that cold space could not coax out. Heat changes everything. Ices sublimate. Metals glow. Surfaces fracture. And in those transformations, hidden structures sometimes emerge. The spacecraft near Mars had long since completed their observational roles, but their data continued to dominate late-night conversations in labs and mission centers. Analysis was progressing, slowly and methodically, but the closer the object came to the Sun, the more the outside world's excitement grew. News outlets began running daily. Perihelion countdowns. Social media filled with dramatic animations showing the comet swooping toward the solar inferno, its green tail trailing like a celestial banner. And in online communities, theories became bolder, stranger, and more elaborate. Everyone was waiting for something, anything, that might give a clue about what 3I Atlas truly was. Inside ESA and NASA, something else stirred, the first leaks. They weren't official releases, but whispers. A blurry image posted anonymously on a private forum. A fragment of a spectrum discussed in a small Discord group frequented by astrophysics enthusiasts. A line in a technical paper accidentally published too early, and then quickly withdrawn. Each of these fragments acted like sparks thrown onto dry tinder. Speculation erupted instantly. Some of the leaked imagery appeared to show the nucleus as more structured than expected, elongated, angular, and irregular in ways that natural erosion doesn't usually produce. Others showed subtle light curves hinting at complex rotational dynamics. Most scientists dismissed the leaks as either misinterpretations or preliminary drafts not meant for public consumption. But it didn't matter. The leaks gave shape to what had been, until then, pure speculation. Suddenly, the public wasn't just imagining a strange comet. They were imagining something built, something with surfaces and edges, something that might not be entirely natural. Speculative memes flooded the internet, depicting the object as a colossal alien ark, a derelict starship, a massive interstellar probe scanning the solar system. Amateur modelers posted elaborate 3D renders of structures that no real data supported, but the narrative had taken on a life of its own. Meanwhile, professionals focused on a more grounded mystery: thermal evolution. As the comet approached perihelion, its surface would experience intense solar heating. For typical comets, this triggers dramatic increases in activity. Jets of gas burst forth, tails grow brighter and more turbulent, and sometimes, nuclei fracture under the stress. But early infrared measurements from spaceborne solar observatories suggested something unexpected. The green coma remained surprisingly stable, showing neither the chaotic surges nor the violent fragmentation seen in most comets near the Sun. Instead, its outgassing levels fluctuated gently, almost rhythmically, in patterns reminiscent of the brightness pulses observed earlier near Mars. This behavior baffled comet specialists. If the nucleus was indeed as massive and dense as Mars data suggested, its surface should have reacted strongly to the Sun's heat. Instead, it seemed oddly resistant, as though wrapped in something that controlled or limited its activity. Speculative, some wondered whether it might have an unusually thick crust of metal-rich material, shielding volatile ices beneath. Others proposed more exotic explanations, that the object's activity was being vented through a limited number of stable fractures or vents, perhaps even arranged in a regular pattern. The perihelion passage, they hoped, would clarify these mysteries. But so far, it only deepened them. As the Sun drew closer, the object disappeared completely from view. The solar glare was now too intense for even the most advanced ground-based telescopes, and space observatories like Hubble and Webb were not positioned to observe it at this angle. Humanity was effectively blind again, except for solar spacecraft like SOHO and Stereo, which would get their chance to observe the comet as it passed near the Sun. These solar sentinels, designed to monitor coronal mass ejections and solar storms, now had a new, unexpected role: to watch an interstellar visitor navigate the Sun's domain. Inside mission control centers, attention shifted toward these solar observatories. Engineers prepared real-time data streams, adjusting algorithms to account for the object's trajectory. The comet's perihelion wasn't just an astronomical curiosity. It was an opportunity to observe how something from another star behaved under extreme solar conditions. If there were hidden structures, hollow cavities, or dense cores, perihelion heating might reveal them through changes in brightness, unexpected jets, or structural fragmentation. In some ways, this was the solar system's version of an X-ray scan. Meanwhile, the public anticipation reached fever pitch. Every science channel, podcast, and late-night talk show seemed to be discussing 3I Atlas. People debated whether perihelion would reveal the comet's true nature or whether it would simply melt away like countless others. A growing chorus of voices demanded that NASA and ESA just tell the truth, convinced that the agencies were withholding evidence of something extraordinary. Scientists, in turn, struggled to keep the discussion anchored in reality, pointing out that data analysis takes time and that speculation often outpaces fact by many light years. Inside the scientific community, the mood was electric but cautious. Researchers knew that perihelion could make or break many theories. If the object fragmented dramatically, it might provide clues about its internal structure but also destroy the very thing they were trying to study. If it remained intact, that too would be revealing, and potentially even stranger. After all, how could a massive, dense, possibly metallic object maintain stability while passing so close to the Sun without catastrophic stress fractures? Late one night, as the comet closed in on its closest approach, a small team at ESA gathered around a set of live SOHO images. The object was still faint, just barely distinguishable from the searing solar background. But even in these grainy frames, something stood out. The coma seemed unusually compact, hugging the nucleus more tightly than expected. Instead of a chaotic, expanding cloud of vapor, it looked controlled, almost restrained, like steam venting through narrow pipes instead of a burst dam. One engineer stared at the screen for a long time before murmuring, "That's odd." The remark hung in the room like a spark in dry air. They couldn't yet say what it meant. It could be a processing artifact. It could be an angle effect. It could be nothing at all. But deep down, everyone watching those screens understood, perihelion would not bring closure easily. If anything, it seemed poised to unravel more layers of the enigma. And out there, in the blinding light near the Sun, the green interstellar wanderer continued on its path, silent, massive, unyielding, as if indifferent to the storm of human curiosity swirling behind it. The moment of perihelion arrived like a silent crescendo. For weeks, the world had been counting down toward this precise alignment, a single point along a vast, ancient orbit where the visitor from the stars would brush past our Sun, exposed to unimaginable heat and gravitational stress. And then, quite suddenly, the countdown was over. There was no fanfare in space itself. The comet moved on without hesitation, as if indifferent to the billions of eyes fixed upon it. But on Earth, the atmosphere was electric. Scientists didn't sleep. Networks didn't blink. Every available solar observatory was pointed, either directly or indirectly, toward that narrow band of light where 3I Atlas would pass. The spacecraft SOHO and Stereo, positioned strategically around. The first images that arrived were almost useless. Static solar flares, saturated pixels. But gradually, through careful analysis, something emerged, a tiny, stubborn point of light, trailing a faint, almost delicate green veil. The nucleus itself was almost lost in the glare, but the coma shimmered faintly, eerily stable. One scientist compared it to a lantern held up against a roaring fire. In most perihelion passages, comets either flare violently or shatter under solar pressure, leaving chaotic, tumbling fragments. But 3I Atlas held its shape. Frame after frame, hour after hour, the point of light persisted. Then, about 12 hours before perihelion, the first anomaly. A spectral analysis team working on SOHO data noticed something subtle. The comet's green coma began to pulse. The pulses grew stronger as perihelion approached. Each wave expanded through the coma with perfect regularity, almost too perfect. Natural jets tend to flicker and stutter, influenced by cracks and irregular outgassing. These waves were smooth, coherent, almost engineered in their precision. Speculative, a few stunned analysts whispered the unthinkable. "It looks like it's modulating itself." Publicly, the data remained under wraps for the moment. But leaks are inevitable. Within hours, snippets of the pulsing coma footage appeared on social media. Someone from a European data lab had recorded a live feed and posted it anonymously. The video, only a few seconds long, showed the faint green halo breathing in and out against the searing solar backdrop. The effect was hypnotic, unsettling, and utterly unlike anything seen from a natural comet. Within minutes, it went viral. Millions watched, transfixed, as if witnessing the heartbeat of some sleeping colossus passing by our Sun. Meanwhile, scientists scrambled to interpret the phenomenon. Was it some previously unknown thermal oscillation? A resonance between solar radiation pressure and the comet's unusual shape? Or was the nucleus releasing gas through a network of vents that happened to produce periodic waves? None of the existing comet models fit the data neatly. And then, at the very peak of perihelion, a second, more dramatic anomaly arrived. In one critical series of stereo frames, the green coma suddenly collapsed inward, shrinking rapidly toward the nucleus. For a terrifying moment, many believed the comet had fragmented catastrophically, that its nucleus had shattered and the coma was dissipating. But then, almost as quickly, the coma re-expanded, brighter and denser than before. This wasn't disintegration. It was something else entirely. A sudden venting event? A reflective flare? A structural shift in the nucleus? No one could say. But the brightness curve spiked sharply, then stabilized again, as if the object had weathered some immense internal adjustment. Gravitationally, perihelion is a crucible. The tidal forces are immense. The differential pull across even a small object can crack it like glass. Thermal stress can vaporize ices, fracture crusts, peel away layers. And yet 3I Atlas emerged intact. No fragmentation trails. No debris clouds. Its core remained whole. For many researchers, this was perhaps the most shocking revelation of all. Objects this large and dense, under this kind of stress, don't just hold together easily, unless their internal structure is far stronger than typical cometary rubble piles. It was as if the object was forged, not fragile. Around the world, media outlets covered the perihelion passage like a global sporting event. Live broadcasts from mission control rooms, breathless commentary from experts, animations showing the comet's trajectory, all feeding a mounting sense that this moment was historic. As real-time data trickled in, headlines flashed. Interstellar visitor survives closed solar pass. Mysterious green object defies expectations. No fragmentation detected, scientists stunned. But beneath the excitement was a growing sense of unease. The pulsing coma pattern had not ceased. Even as the object receded from the sun, the rhythmic brightening continued, slower now, but unwavering. Speculative, some theorized it was caused by rotational harmonics, perhaps a spinning elongated nucleus with jetting vents. Others, more daringly, suggested it might be emitting controlled plumes, regulating its thermal stress in a way natural bodies simply can't. Privately, a handful of senior mission scientists gathered for an emergency closed-door meeting. The perihelion data was still raw, but one thing was clear: the object was not behaving like any comet on record. Its structural integrity, its thermal response, its pulsating activity, all of it defied established models. The question looming in the air was one no one dared to state plainly: what exactly had just passed through our inner solar system? Meanwhile, the comet began to emerge from solar glare, faint but visible once more to telescopes on Earth's night side. Amateur astronomers were the first to pick it up, reporting a brighter-than-expected post-perihelion coma, tinged with that same ethereal green. The nucleus seemed unchanged, but something in its aura was subtly different now, more sharply defined, as if perihelion had scoured away a thin veil and left the core exposed. Observatories around the globe scrambled to get time on their instruments. Everyone wanted a look at what had survived the sun. For the broader public, the perihelion passage felt almost mythical. Billions had watched as something alien threaded its way through the most dangerous region of our solar system and emerged unscathed. It was as though a visitor had walked through fire without burning. For scientists, it was both exhilarating and deeply disquieting. Data would take months, even years, to fully analyze. But the first impressions were clear: 3I Atlas was not just unusual, it was unprecedented. And somewhere, far out in the brightening darkness beyond the sun, the green wanderer continued its trajectory, heading toward the outer solar system. Silent, massive, and now, more mysterious than ever. The days following perihelion felt strangely suspended, like the quiet after a storm whose echoes still rumble beyond the horizon. For a brief moment, humanity had been united in collective awe, watching the green wanderer thread its way through the solar inferno. And now, as it emerged on the far side of the sun, a new kind of anticipation set in, not the tense waiting for survival, but the thrill of rediscovery. Telescopes around the world turned their attention back to the night sky, scanning the regions where the comet should appear, waiting for that first renewed glimpse of the interstellar visitor. It happened sooner than expected. Only 5 nights after perihelion, an observatory in Chile captured a series of deep-field images showing a faint green dot moving steadily against the stars. When the data was stacked and processed, the signature became unmistakable. There it was again, the same shimmering emerald halo, luminous and strangely crisp in its contours. What shocked astronomers most was its brightness. The object appeared brighter after perihelion than before, even though it was now farther from the Sun. This is the opposite of what happens to normal comets, which typically dim quickly once they pass their closest point. The brightness anomaly triggered immediate speculation. Some proposed that perihelion had exposed new layers of volatile material, causing a delayed outgassing surge. Others argued that dust and reflective particles had been redistributed, increasing the coma's reflectivity. But a small minority raised another possibility, speculative. Perhaps the object had stored energy during its solar passage and was now slowly releasing it in a controlled manner. No known comet behaves this way, but then again, no known comet had survived perihelion in quite this fashion either. Space agencies had been preparing for this moment for months. As the comet re-emerged into the dark sky, a coordinated observation campaign swung into action. The James Webb Space Telescope and Hubble were both tasked with tracking it again, now that the sun's glare had faded. Their ultra-sensitive instruments captured the coma in exquisite detail, revealing complex filamentary structures that twisted and curled like delicate threads of smoke. Spectroscopic analysis began anew, hunting for any signs of chemical transformation during perihelion. If anything in the object's composition had changed, now was the time to find it. The Mars missions were still processing their data, but the first telemetry previews hinted at surprises. TGO's spectrometers had recorded unusual nickel signatures even during perihelion, and now scientists were eager to see whether these persisted. Meanwhile, Mars Express's Cassis camera had captured sequences that might help refine size estimates of the nucleus, though the exact shape remained elusive. Some frames hinted at an elongated form, others at something more irregular. If the object truly had the mass inferred from its trajectory, tens of billions of tons, understanding its structure was crucial. Back on Earth, the comet's renewed visibility stirred public imagination to fever pitch. News networks ran nightly segments showing updated trajectories. Online forums and amateur astronomy groups buzzed with images and speculation. People gathered in dark fields with binoculars and small telescopes, hoping for a glimpse. In some rural areas, reports emerged of a faint green glow visible to the naked eye, especially under clear, moonless skies. Whether this was true or simply wishful perception didn't matter. The cultural moment had arrived. 3ILS had become not just a scientific phenomenon but a global mystery, woven into nightly conversations, late-night shows, and whispered campfire stories. As the comet moved outward, the pulsing phenomenon observed during perihelion did not vanish. Telescopes equipped with high-precision photometers began to pick up the same rhythmic fluctuations in brightness, albeit fainter and slower. The pulses seemed to lengthen as the object receded, a kind of decelerating heartbeat. Speculative, some astrophysicists proposed a model in which the nucleus itself was spinning at a constant rate, but the observed brightness oscillations were tied to jets firing in a precise, repeating pattern, perhaps controlled by internal structural harmonics. Others pointed out that if the object were even slightly artificial, this might represent some form of energy regulation or signal. Officially, no agency entertained that idea. Unofficially, no one could ignore the data. The European Southern Observatory conducted one of the most detailed post-perihelion imaging campaigns, using its very large telescope in the Atacama Desert. Under perfect atmospheric conditions, they managed to capture the coma at extraordinary resolution. What they found startled even the seasoned observers. Instead of the diffuse, ragged cloud typical of comets, the coma displayed sharp boundaries, as if contained by some invisible structure. In time-lapse sequences, faint ripples moved through it like waves through a calm lake. Natural processes can produce wavefronts, but rarely so uniform and coherent. This added weight to the growing sense that 3I Atlas was not simply weird, it was unprecedented. Meanwhile, in mission control centers across the world, discussions turned to interception. Could a probe be sent to rendezvous with 3I Atlas before it left the solar system? The idea was tantalizing but fraught with challenges. Its velocity was immense, its trajectory already carrying it toward the outer planets at breathtaking speed. Designing a mission on such short notice would require technological leaps and extraordinary political coordination. But whispers began. Perhaps a modified upper stage could be repurposed. Perhaps a gravity assist from Jupiter could be timed just right. Speculative, some private aerospace firms even floated the idea of launching a high-velocity CubeSat swarm to catch up and photograph it in transit. But for now, observation was the priority. NASA and ESA teams focused on refining their trajectory models, feeding in the new post-perihelion data to see if any deviations appeared. If the object behaved like a conventional comet, the models should match cleanly. But if non-gravitational accelerations, subtle, jet-driven pushes, began to emerge, that could hint at internal processes not yet understood. So far, to everyone's amazement, 3I Atlas remained eerily stable, almost as if guided by an invisible hand. This stability, combined with its massive core, puzzled dynamicists. Typical comets exhibit noticeable trajectory shifts as outgassing acts like thrusters, nudging their paths unpredictably. But 3I Atlas glided onward like a colossal stone, indifferent to the usual forces. This suggested either that its jets were perfectly balanced, an improbable coincidence, or that its surface activity was minimal, with most of its mass shielded by a tough, refractory crust. The latter possibility aligned with the nickel abundance measurements, hinting at a metallic or rock-rich composition unusual for interstellar bodies. Through October and into early November, the comet became a nightly companion to both professionals and amateurs. Its arc through the constellations was plotted with near-religious attention. For some, it became a kind of celestial pilgrimage, a reminder that the universe is vast and unpredictable. For others, it was a puzzle begging to be solved. Scientists carefully kept their language measured in public, emphasizing that many anomalies could have natural explanations. But behind closed doors, in lab meetings and late-night Zoom calls, phrases like unprecedented thermal behavior and structural coherence anomalies were becoming alarmingly common. The sense was growing that perihelion had changed the object, or perhaps revealed its true nature. Whatever it was, 3I Atlas was now the most scrutinized body in the solar system. And yet, even as we pointed every telescope we had at it, the Green Wanderer moved farther away, slipping slowly into the cold and darkness from which it had come, leaving us with data, with questions, and with the uneasy feeling that we were only beginning to understand what had just crossed our path. The world had entered a strange kind of intermission. The brilliant green traveler had passed Mars, survived the sun, and emerged into the darkness beyond. But now, all eyes were fixed on something less visible, the incoming data. The fleet of Mars orbiters, landers, and rovers had been watching 3I Atlas from a unique vantage point during its flyby, and their instruments had recorded terabytes of information. But that raw data doesn't arrive in neat, cinematic bursts. It trickles in, packet by packet, across deep space communication networks, to be carefully unpacked, calibrated, cleaned, and interpreted. This period, days turning into weeks, was where discoveries often quietly begin. At first, there was little official news. NASA and ESA spokespeople repeated the same cautious lines during press briefings. Data processing was underway. Calibration was essential. Science takes time. But behind the public facade, teams across multiple continents were already poring over fragments of the Mars observations, racing to be the first to interpret what might become historic results. And in the absence of concrete announcements, rumors began to spread like sparks in dry grass. The first whispers came from within the European Space Agency. A handful of researchers, speaking anonymously to colleagues, hinted that the trace gas orbiter's spectrometers had picked up unexpected signatures during the comet's closest approach. They didn't specify what kind, but the wording alone was enough to set the scientific community buzzing. Unexpected signatures could mean anything: rare gases, exotic ices, metallic vapors, or something entirely unclassified. A few days later, someone leaked a snippet of an internal email chain discussing persistent high nickel line intensities, apparently recorded over several hours during the flyby. That fit previous reports of unusual nickel abundance, but the context implied something new, something sustained and coherent rather than a brief anomaly. Then, almost simultaneously, rumors emerged from the Mars Express team. According to several independent sources, the high-resolution Cassis camera had captured sequences during the encounter that revealed unusual nucleus behavior. No images were released, but the way scientists suddenly stopped commenting publicly spoke volumes. Internal security measures tightened around data servers. Some forums noted that remote access privileges for several external collaborators were abruptly suspended. The atmosphere shifted from cautious excitement to palpable tension. Publicly, the agencies maintained their silence. But the internet does not wait. Amateur analysts began scouring the deep space network logs, looking for transmission spikes that might correspond to data dumps. Every surge of packets became a topic of discussion. Social media lit up with theories, some wild, some disturbingly well-informed. People tracked spacecraft communication schedules and tried to guess when critical observations had been downlinked. In this digital vacuum, speculation flourished. Among the more grounded rumors was the claim that the TGO spectrometer had detected a persistent spectral line matching a rare nickel compound not typically found in comets, one that would require high temperatures or industrial-like processes to form. Speculative, a few daring commentators suggested this could indicate not just unusual composition, but perhaps some form of surface processing or even internal heating. This was purely conjectural, of course, but it fit eerily well with the object's perihelion behavior and its uncanny structural stability. Another persistent thread revolved around the pulsing coma phenomenon. Amateur astronomers had continued to observe brightness oscillations post-perihelion, and now people wondered whether Mars-orbiting instruments had caught a closer, clearer look at this pattern. If so, the data might reveal whether the pulses were purely photometric quirks or had some underlying physical cause. Some speculated that if the pulses were detectable spectroscopically, they could indicate rhythmic jetting from the surface, or something stranger still. In late October, a leaked technical slide deck from a Mars mission coordination meeting began circulating on private forums. It was quickly scrubbed from most sites, but not before copies spread. The slides were dry, filled with telemetry graphs and calibration notes, but one page stood out, a spectral time series plot showing repeating emission line intensities over a 16-hour window during the flyby. The lines were faint but perfectly periodic. No labels identified the compound responsible. Across the bottom of the slide, a handwritten note was visible in the scanned image. Not instrumental. Pattern holds through 4 calibrations. That single note ignited a firestorm. If authentic, it meant the periodic spectral signal was real, not a data artifact. Scientists debated furiously on professional mailing lists, while enthusiasts dissected every pixel of the leaked plot. Some argued that periodic emissions could result from a rotating nucleus with localized active regions venting gas in a repeating cycle. Others countered that the regularity implied something more organized than any known cometary activity. Speculative, a few even proposed that the signal might represent a kind of resonance or structured release process, like vents opening and closing in a coordinated pattern. Through all this, NASA and ESA stayed silent. Officially, there was no comment on leaked or unverified materials. Unofficially, some researchers dropped cryptic hints on their personal accounts, talking about the most complex dataset of our generation, and a flyby that will take years to fully interpret. One particularly respected planetary scientist tweeted simply, "If this holds up, textbooks are about to get heavier." Meanwhile, the comet itself drifted outward, away. Its green halo remained visible through telescopes, now trailing a longer, more diffuse tail as solar radiation pressure pushed dust and gas into the void. Its pulsing signature continued, slower now, but detectable. Each passing night, it became fainter, slipping gradually toward the edges of telescope capability. This deepened the sense of urgency. The further it moved, the harder it would be to gather new observations. Whatever clues existed in the Mars flyby data had to be found now, before the object slipped back into interstellar darkness. Scientists felt this pressure acutely. In laboratories and mission centers, teams worked around the clock to cross-reference data from multiple instruments. TGO's gas spectrometer readings were being compared against Mars Express imagery. Rover's surface-based observations, though limited, offered complementary angles. Even Perseverance's Mastcam-Z had caught faint traces of the object's coma during the flyby, providing atmospheric calibration points. The puzzle pieces were scattered, but if they could be assembled, they might finally reveal what lay beneath that glowing green veil. But as October gave way to November, it became clear that no single piece of data would deliver a simple answer. 3I Atlas was not a puzzle that could be solved with one revelation. It was a layered enigma, each discovery leading not to clarity but to deeper questions. The waiting period wasn't just about time delays and calibration. It was about the slow realization that humanity might be facing something truly outside our previous experience. And so the world waited, scientists in their labs, enthusiasts with their telescopes, the public with restless curiosity, as the comet receded into the darkness, leaving behind streams of data, unanswered questions, and a growing sense that something extraordinary had just brushed past Mars and the Sun, and was now silently disappearing into the night. The night sky in early November carried a strange sense of farewell. The green wanderer still glimmered faintly, threading its way through the constellations, but already its brilliance was dimming. It was moving away now, away from the Sun, away from Earth, away from the intense scrutiny that had briefly illuminated every facet of its passage. For a fleeting moment, it had been close enough to study with unprecedented clarity. Now, each night placed it farther from the instruments that had captured its secrets. Yet paradoxically, the sense of urgency on Earth was growing, not fading. Because everyone understood one thing: this was a once-in-a-lifetime opportunity, and time was running out. The object's future trajectory was now mapped with exquisite precision. Its outbound path curved gracefully away from the inner solar system, angled just slightly relative to the plane of the ecliptic, carrying it toward the vast domain beyond Jupiter. Calculations showed that by mid-2026, 3I Atlas would be well past the orbit of Saturn, its green halo likely faded into invisibility for all but the most powerful instruments. By 2027, it would be beyond the reach of Webb and Hubble. After that, it would slip into the cold, dark outskirts, joining the ranks of the stars from which it came. It was a slow-motion goodbye, but a permanent one. If humanity didn't act soon, it would lose its best chance to uncover the truth. Space agencies knew this, and plans that had once seemed impossible were suddenly being discussed with a seriousness that surprised even veteran mission planners. Normally, A mission to chase an interstellar object would require years of design, testing, and launch preparation. But 3I Atlas had upended all expectations with its trajectory, mass, and sheer strangeness. What had begun as a curiosity was rapidly becoming a strategic priority. Meetings were held behind closed doors at NASA, ESA, and even private aerospace companies. Could a probe be launched quickly enough to intercept it before it escaped forever? The technical challenges were immense. 3I Atlas was moving fast, much faster than any conventional spacecraft could match under normal mission timelines. Its outbound velocity relative to the Sun was enormous, meaning any chase mission would need either a dramatic gravity assist or advanced propulsion to catch up. Some engineers floated the idea of using solar sails, leveraging sunlight for constant acceleration. Others discussed nuclear thermal propulsion, a technology long theorized but never deployed operationally. Speculative, a bold concept emerged, launching a small, ultralight probe on a high-energy trajectory using the Space Launch System or Falcon Heavy, performing a close solar flyby to slingshot toward the object at unprecedented speeds. The mission would be risky, experimental, and unprecedented, but it might just work. Meanwhile, astronomers refined their observation schedules for 2026. Though the object would fade, its trajectory carried it past several advantageous viewing geometries. In early spring, it would align with Earth's night side again briefly, allowing a second window for ground-based telescopes to observe its coma and tail under darker skies. This would likely be the last good opportunity for amateur astronomers to glimpse it. By summer, only professional instruments would still be able to track it, and by autumn, only deep space observatories like Webb might catch faint echoes of its reflected light. Plans were underway to maximize this final observational season. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and a network of radio telescopes were all coordinating to capture simultaneous data, hoping to detect any lingering anomalies in the coma structure, tail dynamics, or spectral lines. A special proposal was submitted to dedicate extended Webb time to 3I Atlas during this outbound phase, something usually reserved for exoplanets and deep field surveys. The justification was simple. No other known object offered such a unique glimpse into interstellar material, or possibly something more enigmatic. In parallel, the Mars data analysis was entering a critical phase. The raw observations had now been fully transmitted to Earth, and teams were deep into the painstaking work of cross-calibration. Early results were beginning to leak, sometimes intentionally, sometimes not. Several independent labs confirmed persistent nickel signatures across multiple instruments, and a few claimed to have identified non-terrestrial isotopic ratios in the gases trailing the object. If confirmed, this would be explosive, proof that 3I Atlas carried material forged under conditions very different from our solar system. It would mean we were studying not just a visitor, but a messenger from another stellar nursery entirely. And yet, beneath the excitement, a thread of unease ran through the scientific community. Because the object wasn't behaving like a passive rock drifting through space. Its pulsing behavior had not disappeared. Even in its dimming state, high-precision photometric measurements continued to record faint, periodic oscillations. The intervals between pulses were lengthening as it moved away from the Sun, but the structure of the pattern remained remarkably stable. If this were merely the result of rotation and venting, as some models suggested, the regularity should have degraded over time. Instead, it held steady, like a signal that refused to fade. Speculative, a few researchers quietly began treating the pulses not just as physical phenomena, but as potential information carriers. They applied signal processing algorithms usually reserved for radio astronomy and communications engineering, searching for patterns buried within the brightness fluctuations. So far, nothing conclusive had emerged. But the very fact that such analyses were being attempted hinted at how deeply the object's behavior had unsettled even seasoned scientists. Something about 3I Atlas didn't fit neatly into existing categories, and human curiosity, once ignited, doesn't let go easily. Meanwhile, cultural fascination with the object continued to grow. Documentaries were in production. Books were being rushed to print. Conspiracy theories flourished online, some fantastical, others eerily plausible. People debated whether this was a natural fragment from a distant system, a derelict probe, or something even stranger. The mystery had become part of the global cultural fabric, like Oumuamua before it, but magnified 100-fold by the sheer volume of data and the drama of its solar passage. Late-night hosts joked about it. Philosophers wrote essays about humanity's place in the cosmos. Children drew pictures of glowing green ships sailing between stars. Through all this, the comet, or object, or whatever it truly was, sailed on. Silent, steady, unyielding. Its course carried it into deeper space, into colder, darker realms where sunlight waned and human instruments struggled to follow. But it left behind a trail of questions, like glowing embers scattered in the night. Why the nickel? Why the pulsing? Why the structural stability? And perhaps most haunting of all, what was its true origin? By the end of 2026, the first definitive trajectory refinement reports would be published, incorporating all post-perihelion data. These would lock in its outbound speed and direction with such precision that future generations could, if they wished, launch missions to chase it decades from now. But for those alive today, the window of opportunity was short. If humanity wanted to follow, it would have to act quickly, decisively, and perhaps boldly. Because 3I Atlas was leaving, and it wasn't coming back. By the time winter 2026 arrived, a strange quiet had settled over the astronomical community. The furious rush of early observations, the excitement of the Mars flybys, the feverish debates in labs and observatories, all of it had begun to slow. 3I Atlas was now well beyond the orbit of Jupiter, its green glow invisible to any human eye. Only the cold, unwavering gaze of deep space telescopes continued to track its fading trail. But the mystery it left behind hadn't dimmed with distance. If anything, it had deepened. For decades, astronomers had searched the heavens for interstellar visitors. Before 2017, none had been seen. Then came Oumuamua, a silent, cigar-shaped traveler that slipped past too quickly for proper study. 2 years later, Comet Borisov confirmed that such wanderers existed, carrying the chemical fingerprints of other stars. But 3I Atlas was something different. Its timing, structure, and behavior had ignited questions that couldn't be easily dismissed. It had entered our solar system like a messenger with a cryptic script, and then, just as suddenly, it was leaving again. The questions it raised were not just scientific. They were existential. What if objects like this were more common than we had ever realized? What if our solar system wasn't just a passive host, but a crossroads through which unknown travelers passed in silence? What if some of those travelers were natural, and others were not? It was around this time that a series of closed-door conferences began to be held in Europe and the United States. Officially, they were described as multidisciplinary symposia on interstellar object research. Unofficially, everyone knew what they were about, 3I Atlas. Representatives from NASA, ESA, academic institutions, and private aerospace companies were joined by specialists in fields that, until recently, had nothing to do with comets: cryptographers, information theorists, materials scientists, and even a few linguists. Speculative, the pulsing pattern had proven too regular, too persistent, to ignore completely. Even skeptics agreed that something unusual was happening, even if the explanation was ultimately natural. But if it wasn't natural, then humanity might be looking at its first tangible sign of something truly alien. Meanwhile, public fascination had reached fever pitch. Late-night talk shows filled with speculation. Online communities dissected telescope images pixel by pixel, looking for hidden shapes. Some claimed to see structure beneath the coma, like ribs beneath translucent skin. Others believed the pulsing was a transmission, encoded in brightness instead of radio waves. Scientific journals scrambled to keep up with the flood of preprints, many of them contradictory, some breathtakingly bold. There were papers suggesting exotic ices sublimating in strange periodic cycles, others proposing alien solar sail fragments, and a few daring to hint at engineered behavior. For every hypothesis, there was a counter. For every confident statement, a new anomaly emerged. Through it all, 3I Atlas itself remained silent. It did not change course. It did not speed up or slow down. It simply drifted outward, indifferent to the storm of speculation it had unleashed. There was something haunting in that silence. As if the object had arrived, delivered its riddle, and was now vanishing back into the starfields, leaving humanity to puzzle over the pieces. One of the most haunting images came not from NASA or ESA, but from an amateur observatory in the high deserts of Chile. In a long-exposure image taken just days before the object slipped beyond the reach of most telescopes, the green coma appeared as a ghostly blur against the starfield. But if you stared at it long enough, a subtle asymmetry emerged, a faint, almost imperceptible, crease, along one edge, like the fold of a sail catching invisible wind. Most dismissed it as an imaging artifact. But to those who wanted to believe, it was a tantalizing clue. Speculative, could it have been a structure, barely visible beneath the luminous gases? Could this traveler have carried something within? The philosophical impact of the event was immense. Scientists and philosophers alike began to speak of a new interstellar awareness. Humanity had always known, intellectually, that the stars were vast and full of mysteries. But 3I Atlas made that reality tangible, immediate, and strangely intimate. It wasn't just distant starlight anymore. It was an object, a presence, that had passed through our neighborhood and left fingerprints no one could fully explain. It forced people to confront how little we truly understood about the cosmos. For centuries, Earth had looked outward, searching for signs of life among the stars. Radio telescopes scanned the skies, space probes ventured into the void. But what if the first real sign of something else didn't come as a message beamed from afar, but as a silent traveler drifting close enough for us to glimpse it, but not close enough to fully know? 3I Atlas had shown that the universe might not announce its secrets with fanfare. It might whisper them, fleetingly, through passing enigmas. As the object receded, one question began to dominate both scientific papers and late-night discussions alike. Was this the beginning of a pattern? Would there be more? Already, surveys like the Vera Rubin Observatory's Legacy Survey of Space and Time were gearing up to scan the sky with unprecedented sensitivity. Statistically, more interstellar visitors were almost certain to follow in the coming decades. But none would ever be exactly like this one. Its green coma, its pulsing light, its stable structure near Mars, these were signatures that set it apart. If this was the first of a new kind of visitor, then humanity had just witnessed the opening act of a story that might unfold over generations. There was a growing sense that something had changed permanently. Astronomers began quietly adding new watch lists to their survey protocols, tuned not just for ordinary comets but for objects with anomalous behavior, unusual brightness fluctuations, unexpected materials, non-standard trajectories. The search had widened, not just in scope, but in imagination. Before 3I Atlas, the cosmos had seemed distant and largely predictable. After it, the stars felt closer and stranger. And then there was the question that lingered like a soft echo in every conversation: what if it wasn't the only one watching? Speculative, some proposed that such objects might serve as passive probes, drifting silently between systems, collecting data, or perhaps waiting for the right kind of attention. Others dismissed the idea entirely, grounding themselves in natural explanations. But even among the skeptics, there was a quiet acknowledgement that the line between natural and artificial, between random and intentional, was sometimes thinner than we like to admit. Whatever the truth, 3I Atlas had left its mark. Its path across the night sky had been brief, but its impact would resonate for decades. Children who had looked through telescopes to see its green glow would grow up in a world where the possibility of interstellar visitors was no longer theoretical. Engineers would design missions with quicker launch windows and higher velocities. Philosophers would revisit age-old questions about contact, isolation, and cosmic destiny. And somewhere, far beyond the orbits of the giant planets, the object continued its journey, silent, inscrutable, fading into the abyss. Long after 3I Atlas had slipped beyond the reach of any telescope, its memory persisted, not as a single event, but as a quiet ripple spreading through human thought. It was as if the night sky itself had whispered a secret to us, then fallen silent, leaving only the echo of its words. For centuries, we had charted comets, mapped the planets, measured the stars. We thought we understood the language of the heavens. But this visitor had spoken in a dialect we had never heard before, and its meaning remained just beyond reach. The last confirmed images were faint, almost ghost-like. Deep space telescopes captured them against a backdrop of faraway stars, the green coma now diffuse and pale, like a fading lantern drifting into a dark ocean. No spectacular final flare, no sudden course change, no transmission beam back to Earth. Just silence. The object's journey through our solar system ended as it had begun, quietly, almost indifferently, as if unaware of the storm it had caused among the tiny observers clustered around a small blue world. In the control rooms of NASA and ESA, screens still displayed plots of its trajectory, looping outward into the dark between stars. The numbers told a simple story. It would continue on its path for millions of years, wandering between constellations, untouched, unseen, until perhaps one day it slipped into the gravitational well of another star. To the object, our solar system had been just one waypoint in an endless voyage. But to us, it had been everything. Astronomers often speak of perspective shifts. Moments when the familiar suddenly becomes strange, and the universe tilts, revealing a depth you hadn't noticed before. The Mars flyby of 3I Atlas was such a moment. Not because it proved anything definitive, it didn't, but because it revealed how thin the boundary is between what we think we know and what we have yet to learn. In a way, it was less like receiving an answer and more like being handed a better question. For some, the mystery was unsettling. It reminded them of how fragile our understanding really is, how much of the universe operates outside our control, our expectations, our narratives. For others, it was exhilarating. The cosmos had shown us something unexpected, something that didn't fit neatly into our categories, and that meant there was more to discover. Either way, humanity had collectively taken a step into a larger world, one where visitors from other star systems were not legends or distant possibilities, but tangible realities. As the months passed, life on Earth returned to its usual rhythm. The news cycle shifted, other stories took the stage. But in observatories, laboratories, and late-night conversations under clear skies, the mystery lingered. Papers continued to trickle out, refining data, revisiting hypotheses, proposing new models. No single theory satisfied everyone. Perhaps none ever would. Some mysteries are meant to stretch across decades, drawing generations of minds toward them like gravity itself. And yet, something subtle had changed in the way people looked up at the stars. It wasn't dramatic. There were no sudden global revelations, no cosmic announcements. Instead, it was quiet and personal. People began to linger a little longer when they gazed at the night sky. Amateur astronomers tuned their telescopes not just to the familiar planets and nebulae, but to the dark gaps between them, wondering if another green traveler might one day appear. Children asked new kinds of questions. Artists painted scenes of alien messengers drifting through the solar wind. Writers imagined encounters beyond the reach of radio signals. Scientists recalibrated their instruments, preparing for the next whisper from the void. And somewhere, far beyond the icy outskirts of our solar system, 3i Atlas continued its silent journey. No eyes watched it now. No instruments tracked its progress. It was alone again, sailing through interstellar darkness, as it had for uncountable centuries before us, and would for uncountable centuries after. Its coma had long since dissipated, its tail vanished into nothingness. All that remained was a solid, silent core, ancient, enduring, enigmatic. There's something profoundly humbling about that image, a solitary object, drifting through a galaxy that barely notices its passing. It doesn't matter whether it was natural or artificial, comet or construct. What matters is that for a brief moment in cosmic time, our paths crossed. We looked outward, and it passed close enough to look back, not with eyes perhaps, but with its presence. And in that encounter, we were reminded of the vastness we inhabit, and the mysteries that still lie hidden beyond the edges of our understanding. Future missions are already being designed with 3i Atlas in mind. Faster propulsion, better telescopes, more agile detection networks. Humanity learned a lesson from its fleeting visit. If you want to meet the unknown, you must be ready to move quickly. Objects like this don't wait for us. They glide through the solar system on their own schedules, indifferent to our curiosity. The next time something like 3i Atlas arrives, we intend to be ready. But readiness is not the same as understanding. The Green Traveler's visit was not a puzzle with a neat solution. It was a story with no ending, a mystery that slipped through our fingers like interstellar dust. And maybe that's the point. Not every mystery is meant to be solved immediately. Some are meant to stretch our imagination, to remind us that we are part of something infinitely larger and older than ourselves. If you step outside on a clear night and look up, you'll see the same stars that have watched over travelers like 3i Atlas for billions of years. Somewhere among those points of light, other objects are moving, slowly, silently, carrying their own stories. Most will never come near us. But every so often, one will drift close enough for us to notice, and for a brief moment, the universe will speak again. In the end, 3i Atlas didn't give us answers. It gave us something far more powerful, a question. A single object drifting through the solar wind managed to shake the edges of what we thought we knew. It reminded us that the cosmos is not finished surprising us, that between the stars, in the cold and silent dark, there are still stories unfolding, far older and stranger than our own. For a brief moment, humanity stood together beneath the same sky, eyes turned toward a green light slipping past Mars, past the sun, and out into the abyss. Governments, scientists, and ordinary dreamers all shared in the same quiet wonder. And then, like a visitor leaving without a word, it was gone. But its presence lingers, not in the sky, but in us. In our questions. In our readiness. In the quiet space between certainty and mystery. The night is vast, and the stars keep their counsel. Yet now, we listen differently. Because once, not long ago, something came from the deep and passed us by. And somewhere, in the dark between stars, it keeps moving. Silent. Unreachable. But unforgettable. This is not the end of the story. This is only the moment the camera pulls back, and the universe opens wide.